Hello, pre-algebra students. Mr. Rivers here. We're going to start today with section 7.7, writing inequalities. Today's objective is to solve verbal problems or word problems by writing and solving inequalities. Remember inequalities, greater than, less than, greater than or equal to, less than or equal to. So we are taking word problems, converting them into an inequality, and then solving that inequality. Let's go and get started. First off, writing inequalities, we're going to define a variable. Remember, X might represent someone's age. X might represent how many eggs somebody has purchased. X might just represent a number, but we're going to define what our variable represents. We're going to write an inequality. That would be something with a less than, greater than, less than or equal to, greater than or equal to sign, and then we're going to solve. So starting out here, 3 times a number increased by 8 is at least 25. So let's work this one all together. So what does our variable represent? We'll call it X. Okay. Okay, so you want to ask yourself, what is the unknown here? The unknown is a number, right? So we define our variable. X is our number. X is a number. All right. And 3 times a number, 3 times a number, increased by 8, that'd be what? Plus 8 is at least 25. Now let's think about that word at least. This is at least 25. So can it be more than 25 or less than 25? If this is at least 25, it could be 25, 26, 27, 28, right? So this is 25 at the absolute lowest, and everything bigger too. So greater than or equal to. So that's what at least means. We then subtract 9 from both sides. I'm sorry, minus 8, excuse me. Minus 8, and we get 3x greater than or equal to 17. And then we divide both sides by 3, and we get x is greater than or equal to 17 thirds. You could make this a mixed number if you want to, but you don't have to. That is a simplified fraction, so we are done. Here's one you could try on your own. 4 times the number decreased by 6 is at most 30. What is the number? If you haven't done so already, go ahead and pause the video and work on this problem. All right, first we ask ourselves, what is our variable? Make sure you're defining your variable. So I'm going to have our variable be x. And what does that variable represent? It represents a number. So x is a number. Well, 4 times that number, 4 times x, decreased by 6, that means minus 6, is at most 30. All right, so pause for a moment. If this is at most 30, think about what inequality sign goes right there. Pause the video now and think about it if you haven't done so already. Okay, if this is at most 30, could it be 30? It could. Could it be more than 30? No, it can't. At most is the ceiling, right? So this would have to be 30 or 29 or 28 or 29.9. But this is less than, less than or equal to, right? So there's our inequality. We're going to add 6 to both sides. 6 plus 6. 4x less than or equal to 36. We divide by both sides by 4. Let's try that again. And when we divide by 4, we get x. So we get x is less than or equal to 9. All right, here's another one for you. 9 less than twice a number is greater than 11. Find the number. So pause the video now. Try this one on your own. Define a variable, write an inequality, and solve. Pause the video now. All right, well, 9 less than twice a number. So remember, twice a number. 1 second here. It's going to give me. So 9 less than twice a number. So 2 times a number. and then 9 less than that. So 9 less than 2 times the number is less than or equal to negative 20, right? So this one's pretty easy. Less than or equal to. They tell us what the sign is just in the words themselves. Find the number. All right, well, we're going to add 9 to both sides. Plus 9 plus 9. So we get 2x less than or equal to negative 20 plus 9. That gives us negative 11. We now divide both sides by 2. And we get x less than or equal to negative 11 halves. Or if you wanted to, you could make that a mixed number or a decimal. All right, here's 3 more. Try these 3 on your own. Pause the video now. Try all 3. I'll work all 3 out momentarily. Pause the video now. Okay, so x is going to represent a number 9 less than 6 times a number. So 9 less than 6 times a number is at most 33. All right, think about what sign goes here. This is at most 33. Could this be 33? 6x minus 9. Could it be 33? It could. Can it be more than 33? This is at most 33. So no, it cannot. It has to be less than or equal to 33. So this could be 30, 31. It could be 33. We're now going to add 9 to both sides. 6x less than or equal to 42. Divide both sides by 6. X is less than or equal to 7. By the way, I hope you are pausing the video. If you made a mistake at some point, like if you set up this inequality incorrectly and you saw mine, you said, I messed up. That's okay. That happens. But I need you to pause the video, write down what is correct, and then work the rest on your own. Don't just watch me work these problems. Watching me work problems, it's better than doing nothing, but the way you're going to grow the most is by working these problems out yourself and trying to figure them out yourself. So there's a lot of value and growth that happens through trying to do things. All right. If you haven't tried this one out, go ahead and do it. 3 times the number increased by twice the number is greater than 121. What is the number? Pause the video now. Okay, so x is going to represent a number. 3 times a number, that'd be 3x, increased by, that means we're adding, twice the number, 2 times x, is greater than 125. All right, so as we solve this, think about what we need to do. We need to combine like terms first. We can combine 3x and 2x. It gives us 5x. It's greater than 125. We then divide both sides by 5. And x is greater than 25. 125 divided by 5 is 25. So the number is greater than 25. All right, so this one's a little tricky. X is still a number. Pause the video if you've not tried this one out, but try it on your own first. X is a number 3 times the quantity of a number decreased by 1 is no less than negative 12. So this phrasing here, the quantity of, what that means is that's going to happen first before we multiply by 3. So 3 times comes after the quantity of a number, so a number decreased by 1. So how can we show that we need the subtraction to happen before that multiplication? So we're going to multiply this by 3, but we need to subtract before we multiply by 3. Pause if you don't know, think about it. We need parentheses. That is how we can subtract before we multiply. So 3 times the quantity of a number decreased by 1 is no less than negative 12. So if this is no less than negative 12, what's another way to phrase that? 3 times x minus 1 is no less than negative 12. It means this can't go lower than negative 12. Could it be negative 12? Yes, it could, but it can't go lower, which means what inequality sign are we going to have right here? Right? It's no less than, which means it's greater than or equal to. This is no less than negative 12. This can't go lower than negative 12. So now we solve. We use the distributive property first. 3x minus 3 greater than or equal to negative 12. We're going to add 3, It gives us 3x greater than or equal to negative 12 plus 3 is negative 9. Divide both sides by 3. That gives us x is greater than or equal to negative 3. Very good. Let's try a word problem here. Ricky earns $2 for every magazine subscription he sells, plus a salary of $10 per week. How many subscriptions does Ricky need to sell each week to earn at least $40 a week? So if you think you have a handle on this one, pause it. Otherwise, I'll start talking my way through it here and help you out. So if he sells 0 magazines, how much is he going to earn? He still earns 10 bucks. Even if he sells nothing, he earns $10. Now, if he sells 1 magazine, he'll earn $2 for that magazine plus the $10 salary. If he sells 2, well, $2 for 2 magazines, that's $4 plus the $10 salary. So he'll make $14 then. So keep in mind this, he makes $2 for every single time he sells a magazine, but he always gets that $10 added to it. So see if you can't work that out on your own now. Okay, so what is X going to represent? X is going to represent the number of magazines sold. This is the best way to define this variable. If you say X is magazines, X is the number of magazines, that's not totally wrong, but we could be more accurate. If you said X is a number, that's not as, you can do better. So X represents specifically the number of magazines sold. So let's be as specific as possible when defining this variable. So $2 for every magazine he sells, and he's going to make his $10 whether he sells a magazine or not. And he needs to sell enough to make at least $40. Now, could he make more than 40? If you're going to make at least 40, like if you make 50, is that at least 40? It is. So the amount that he makes, this represents how much money he makes, needs to be greater than or equal to 40. We'll subtract 10 from the left, subtract 10 from the right. 2x is greater than or equal to 30. We'll divide both sides by 2. And we get x is greater than or equal to 15. So let's put this in a sentence as well. Pause this and write a sentence out representing this problem. Pause it now. All right, so my pen messed up a little bit here, but you get the idea. Ricky needs to sell at least 15 magazines to make at least $40. All right, let's talk about Neil. Neil has $90 that relatives gave him for his birthday. He needs to buy a new pair of shoes and would like to also buy 2 CDs. The shoes he likes cost $65. How much can Neil spend on the CDs? All right, keep in mind, he only has 90 bucks, so we know he can't spend more than $90. What is he buying that we don't know the cost of? We don't know the cost of CDs. Now remember, how many CDs is he buying? 2. So let that guide you as you solve this problem. Pause the video now and work it if you've not done so already. All right, so X is going to be the cost of 1 CD. Okay, so he's going to buy his shoes. Oh, excuse me. The shoes are going to be $65. And he's going to have to add to that the cost of 2 CDs. Well, if 1 CD is X, 2 times X, that's going to be how much he spends on CDs. Okay, and this is going to be, well, you know he's got $90. That's all he has. Can he spend more than 90? He can't because he doesn't have it. Can he spend exactly 90? He can. Could he spend less than 90? Yes, he could. So let me fix that. All right, so we end up with 65 plus 2x is less than or equal to $90. So we need to get the 2x by itself. So we'll subtract 65 from both sides. Minus 65 minus 65, which gives us 2x. It's less than or equal to 90 minus 65 is 25. We divide both sides by 2. X is less than or equal to 12.5. So write a sentence for what this represents. X is less than or equal to 12.5. All right, so my sentence is something like Neil can spend at most $12.50 per CD. So if you said Neil spends less than or equal to $25 on CDs, that would be okay too. I would take that. All right, try this one out. Hopefully you have the hang of it by now. Lauren buys some candy bars at 55 cents each and one newspaper at 35 cents. How many candy bars can Lauren buy if she has only $2? All right, pause the video if you've not done so. Ask yourself, what is my variable going to represent? Like what could vary? That's why it's called a variable. It could vary, it could change. So what could vary here? And that's going to be your variable. When defining your variable, the key is to look at the question. So the question is, how many candy bars can Lauren buy? So X, we'll say, is the number of candy bars Lauren buys. Okay, so if she buys some candy bars at 55 cents each, if she buys 0 of them, she spends 0 on candy bars. If she buys 1 of them, she spends 55 cents on 1 of them. She buys 2 of them, it's $1.10, right? So 0.55 times X. Okay, and she's going to buy 1 newspaper for 35 cents, so plus 0.35. And she only has $2. Well, if you only have $2, can you spend more than $2? The answer is no, you can't. So it's less than or equal to 2. All right, so if you didn't already solve this inequality, go ahead and solve it on your own here. But I'm going to subtract 0.35 from both sides, minus 0.35. We get 0.55x less than or equal to. All right, when we have 2 and we subtract from it 0.35, if you have $2 and you lose 35 cents, you now have $1.65. Okay. Then we divide both sides by 0.55. So x is less than or equal to, this is going to be 3. All right, so take a moment now, pause the video if you've not done so already, write a sentence that represents what is going on in the scenario. X is less than or equal to 3. Write a sentence that represents this. All right, Lauren can buy up to 3 candy bars. That is my sentence. You should have something similar. All right, try this one out on your own. Austin decides to go to Portland, Oregon over spring break. He rents a car for $139.95 plus 25 cents per mile for each mile over 100 miles. If Austin had budgeted for up to $200 for car rental in his vacation budget, how many miles could he drive and stay within the budget? So if he drives 0, he's still going to spend the $139.95. If he drives 50 miles, he'll spend $139.95. If he drives 100 miles, he'll spend $139.95. Every mile beyond that, he's going to spend 25 cents. So ask yourself, what varies here? What is the variable? All right, so my variable here, x, is going to be miles driven. Okay, well, he's going to spend $139.95 whether he drives a mile or not. We're going to say miles driven, not just miles driven, but it's miles driven over 100 miles. Okay, that's the important part here. Again, if he drives 100 exactly, he still only pays the $139.95. So we're going to add to that 0.25 times x, right? And he wants to budget, or he wants to spend up to $200. So if he wants to spend up to $200, could he spend exactly 200? Yes. Could he spend more than 200? No. Could he spend less than 200? Yes. So the amount he spends, which is this, needs to be less than or equal to 200. All right, so take a moment to solve this if you've not done so already. So we're going to subtract 139.95 from both sides. 139.95. When we do that, we get 0.25 x is less than or equal to, that's going to be $60.05. Okay, from here, we divide by 0.25. So when we divide this out, we get x is less than or equal to 240.2. All right, or if you wanted to say 240 and just round to the nearest mile, that'd be okay with me. So go ahead and pause this and write a sentence to explain what's going on. Be careful on this one. This one's a little trickier than it might first appear. What does this represent? Read what your variable represents and read what you have here. Austin can drive up to 340.2 miles. Now you might be wondering, Mr. Rivers, you should have said 240. The answer is no, I should not have, because remember what X represents. X is the miles driven over 100 miles. He can drive 100 miles and only pay $139.95. So anything up to 100, I'm not going to say it's free, but there's no additional charge for him. So he can drive 240.2 miles above 100, which means he can drive up to 340.2 miles. A little tricky there. Here's a similar problem. Go ahead and pause the video, read it, and solve it. Katie wants to drive from Chicago to LA over spring break. She rents a car in Chicago for $99.95 plus 28 cents per mile for each mile over 50 miles. Her budget for a car rental while on vacation is $250. How many miles can Kate drive to stay within her budget? This is very, very similar to the previous problem. If you are stuck, flip back and watch that one again. All right, so X is going to be the miles driven over 50 miles because anything up to 50 miles, there's no additional charge. Kate is only going to pay $99.95, whether she drives 0 miles or 50 miles. Now, anything over 50 miles, that's where she starts to get charged 28 cents per mile. So X is the miles driven over 50 miles. So $99.95, that is the flat charge she's going to have. We're adding to that 0.28 multiplied by the number of miles over 50 miles. She's budgeted up to $250. So the amount she spends, which is right here, is less than or equal to $250. We solve this by subtracting 99.95 from both sides. We get 0.28x is less than or equal to 150.05. We divide both sides by 0.28. When I round to the nearest tenth, I get x is less than or equal to 535.9. So take a moment now and write a sentence regarding our answer and the question. Write a sentence to answer how far Kate can drive and stay within her budget. Remember, anything up to 50 miles, there's no additional charge. So she can drive 535.9 miles above 50. So we add 50 to this. Kate can drive 589.9 miles and stay within her budget. And that's going to take us to the end. Make sure you check Google Classroom for today's assignment. Complete that and submit it to Google Classroom to receive credit for today's work. Thank you so much for your attention to this video. I really appreciate it. We'll see you next week.